Welcome back. Previously, we discussed a new method for solving simultaneous linear equation using matrices, that is a Cramer's rule. Today, we will discuss further cases that comes under matrices. We were discussing about using Cramer's rule for finding the value of unknown variable. I hope you understand the concept and steps that has to be followed while dealing with the same pattern of question. So try to find the solution. Solution is already given, but you need to find whether you are getting these answers or not. And try to familiarize each method that we are studying. So try to solve these two equations. I hope this method or this equation, we have dealt the same equation previously and try to find the answer. The answer will be the same, but try to find or familiarize the steps that are followed. So just go through it. Next is rank of a matrix. Rank of a matrix actually means every square matrix or a rectangular matrix or any type of matrix. Every matrix has a specific rank. Rank means, as we all know, ranks like a number that are representing each matrices. So a matrix may be ranked on the base of its order of position. Order of position means its order of matrix. We all know what is meant by order of matrix. Order is represented by the number of rows and columns. So if it is a square matrix, it can be represented by 2 into 2, 3 into 3, 4 into 4, and 5 into 5, and it will be going like that. In a square matrix, the rows and columns will be the same. And sometimes you may come across a matrix where it will be a rectangular matrix or an uneven matrix. Uneven matrix means that the rows and columns may not be equal. And we have dealt with a numerous types of matrices that are following the same concept. So all these matrices have a rank. Rank is found on the base of the order of that particular matrix. So a non-zero matrix is said to have rank k. K is the rank given for that matrix. If at least one of its minors is not zero and all minors of order more than k if any are zero. The concept is, whenever you are dealing with a square matrix, for example, if it is a square matrix consisting of 3 rows and 3 columns, so it's in the order of 3. So we were discussing about a matrix, square matrix, in the order of 3. So first of all, whenever you find a matrix, identify its order. So we are discussing a matrix with the order of 3. So the rank of that particular matrix will be 3. That is the concept of this area. And identifying the rank of the matrix is easy. The computation part is actually, you have to prove whether the rank is correct and how you are going to find whether the rank is correct or not. Once you identify the order of a matrix, you can say that the rank of that particular matrix may be in the order of the matrix given. For we were discussing about a square matrix with 3. So the rank may be 3. And how we are going to test that? The concept is, you need to find the minor of that particular matrix. If you are getting a non-zero matrix, then the rank is correct, or the assumption, your assumption will be correct. If you are getting a zero matrix, then the rank is, and that rank will not be the actual rank of that particular matrix. In that case, you have to do some computations. That is the actual concept or logic of finding the rank of the matrix. So the rank of a matrix is said to be 2. If you found a matrix, its order may be anything. You found that its matrix rank is 2. So all the minors of order 3 or more are 0. That means if you have ranked a particular matrix as 2, then all the minors of order 3 or more maybe was 0. So whenever you get a minor of a particular matrix as 0, then the rank will be cancelled. So you have to check for the some other ranks. That is the computation part of the particular rank of a matrix. So if the given matrix is a square matrix, usually you may come across square matrix, it may be a rectangle, depends. We will discuss that both the cases. The highest minor is a determinant formed with all the elements of a given matrix in the same position. If you are dealing with a square matrix of the order 2, in that case you just find the value of determinant. If you are getting 0, then there is no rank. If you are getting any numeric value, whether it is positive or negative, then the rank of that particular matrix will be 2, because we were discussing about order 2. When the matrix order is above 2 means it may be 3 into 3 or 4 into 4 or 5 into 5 or 6 into 6. In that or in all those cases, you have to find the minus. We all know how to find the minus. If you are getting a non-zero value for all the minors of that particular matrix, then the rank will be the order of that specific matrix. That is the concept. We will discuss the further cases with an example. Then you will get a clear picture about the rank of how to find the rank of a matrix. So let's find the rank of a particular matrix. So here a square matrix is given and we know how to specify the order of the matrix. This matrix is in the order of 3 into 3. This is a square matrix of the order 3 into 3 because it consists of 3 rows and 3 columns. So the highest minor that can be obtained is of the order 3, which is, we can assume that the rank of this matrix, because it's order 3, it's in the order of 3, so we can assume that the rank of this particular matrix may be 3. And why we are computing or why we are studying here it is, we are going to find out whether the rank is 3 or not. We are going to prove that whether it is 3 or not. That is the computation part. Finding the rank is easy, but computing to make sure whether the rank, assumed rank is correct or not, that is a computation of actual computation that comes under rank of the matrix. So it's in the order 3 into 3. So we can assume that it may be in the rank of 3. And how we are going to find whether it is 3? We all know how to find the minor of these matrices or determinant of these matrices. When you are finding the determinant, the values selected are first row, and we know how to find the determinant of a certain matrix. So once you solve this particular matrix, you can see that the determinant of this particular matrix is minus 5. Minus 5 means it is not a 0. You just make sure whether you are getting 0 or not. Plus or minus, it doesn't matter. If you are getting 0, then this rank is not the actual rank. Here you got minus 5. Minus 5 means the rank of this particular matrix is 3. That is the concept. Sometimes you might get 0. In that case, you have to do some other steps. We will discuss that adjustment in the next session. Next one, find the rank of the matrix. Another matrix is given. It's in the order. It's actually not a square matrix. It's in a rectangular matrix. So how we are going to find? If it was a square matrix, we can specify the order of the matrix as the rank of that particular matrix. So the order of this matrix is 3 into 4. 3 means 3 rows, 4 columns. So how we are going to specify the rank of the matrix? So there is a note that has to be remembered. If the given matrix is a rectangular matrix of the order m into n means 3 rows, 4 columns, then the highest minor is of order equal to m or n, whichever is less. The meaning of the sentence is, whenever you come across a rectangular matrix, make sure the numbers of that matrix, that is, the order of this particular matrix is 3 into 4. And when you come across that situation, remember you need to select the number whichever is less. In 3 into 4, which is the lower number or which is a smaller number? 3. Then 3 will be the rank of this particular matrix. And your answer didn't complete, you have to prove whether that 3 is correct. That is the part. So whenever you come across a rectangular matrix, remember you need to find out the order of the matrix and you need to select the number whichever is less So this matrix is in the order 3 into 4. So the highest minor that can be obtained are of the order 3. So the rank of this matrix may be 3, and we are going to prove that whether it is 3 or not. So how we are going to prove it? Since it is a matrix, rectangular matrix in the order 3 into 4, you have to split this matrix in the order 3, because you found that 3 may be the rank. So whenever you rank a particular matrix, the order of that matrix has to be 3. Here it is not 3. So you have to split this matrix into 2 so as to cover all numbers, and at the same time the matrix should be in the order of 3. See, we have split this particular matrix into one part, that is 1 2 0 3 1 2 2 4 0. Why we are splitting means we assumed that it may be in the rank 3. So in order to prove it is 3, you have to split this matrix into two parts. So first part is this one, and how you selected this one. See, first you have to find the first 3 rows and 3 columns. First 3 rows, 1 2 3 1 2 3. First 3 rows and 3 columns. That's how you selected the number. There is no other special rule. So you have selected one part of the matrix, and how we are going to select the second part. Second part means you have to cover all the numbers by splitting this entire matrix. So you have split it into one part. So the second part will be 2 0 5 1 2 2 4 0 10. The concept is you have to include all these numbers of the rectangular matrix in these two matrices. So first you select 1 2 0 3 1 2 2 4 0. So you got a matrix of the order 3 into 3. But we have skipped 5 to 10. So here it is a 3 into 3 matrix, and we have skipped this one. So in order to include that, we selected this one, and when you are splitting a matrix, it has to be in the order of 3. That is 3 rows, 3 columns. So if you want this one, 1 2 3. See, that's how we selected or splitted this matrix into these two parts. Once you splitted these two matrices, you have to follow the step which we have learned earlier, and you know how to find the determinant of this particular matrix, and you have to find the determinant of the first matrix which you have splitted from this one. So if you do the computations or the operations which we have learned in the case of determinant, here you got 0. And we can check the other one. Here it is 0, so it may not be the rank 3. So if you follow the determinant operation in the second matrix also, you have to find the determinant in both the cases. It doesn't mean that you have to find only first one. You have to find the determinant of both the matrices. So by using the basic determinant operations, you found the values, and following the basic operation, you will get another 0. And at the beginning, we have learned that if you are getting a determinant of a certain number 0, in that case, the rank may not be the one which you have assumed. We assumed that here the rank of this matrix was 3. But you have got two different values means you got two different matrices, and you use the determinant operations and end up coming 0. In both cases, you got 0. So the rank of this particular matrix is not 3. We assumed it was 3. When by using the computation, we found that it is not the rank of that particular matrix. But it doesn't mean that you have to stop there. You have to find the actual rank of that particular matrix. So the rank of this matrix is not 3. Then how we are going to find the rank? Whenever you found that a particular rank is not the actual one means after computation if you are getting 0 and here it was 3, then you have to go for the next smallest rank. Next smallest rank means if it is 3, next you have to try for 2. 2 means the matrix has to be in the order of 2. So you need to split this matrix into different matrices in the order of 2. 2 means 2 rows, 2 columns. See, it was 3 into 4. You split it into 3. Now you have and found that 3 is not the rank. So you have to go for the 2. Whenever you found the determinant of a matrix as 0, you have to go for the smallest rank. If here it was 3, so you have to try 2. So Now consider the minors of the order 2. Now split the matrix given in the question in the order of 2. So it will be like this. Order of 2 means you have to include all the numbers and at the same time it should be in the order of 2. So first one, 1, 2, 3, 1. 2 rows, 2 columns. So you got first matrix. Second one, 2, 0, 1, 2 and 2, 1, 0, 2. You got another matrix. Next one, 0, 5, 2, 2. You got third matrix. And it's not complete. You have to include this last line. We only took the first 2 lines. You have to include the last 2 lines. Sorry, last line. Next one, 3, 1, 2, 4. Then only you can cover the last line. 3, 1, 2, 4. You may think that 3, 1 is already selected, then why we are again selecting? The concept is you have to cover all the numbers. It doesn't mean that you have took a certain number or certain row in both matrices. It doesn't matter. The matter you have to consider is you must include all the numbers. So next one is 1, 2, 4, 0. See, 1, 2, 4, 0. And finally it is 2, 2 and 0, 10. I hope you are getting the concept. So whenever you come across a question, you have to be very cautious while dealing with rank of a matrix. So you have developed 6 matrices from the matrix which is given in the question, because we assume that the rank of this matrix may be 2, so you have to split that particular matrix is in the order of 2. Now you need to find the determinant or the minor of this particular, because in the case of a 2 into 2 matrix, the minor and the determinant will be the same. So by using the basic operation, you got the value of first one is -5, 4, -10, 10, -8 and 20. If you go through the values of these particular matrices, you can see that none of the matrices value or the determinant value or the minor of these matrices is not a 0. So now you can assume that the rank of this particular matrix is 2. That is the concept of the case, how to find the rank of a matrix. So remember the steps that has to be followed. Whenever you have to find the rank of a matrix, you need to identify the order of the matrix and assume that the order given means if it is a square matrix, the order will be the same and the rank will be the same, and you have to prove whether the rank assumed by you is correct or not. For that, various steps has to be followed. If the matrix is in the order of 3 or more, 3 or more means 3, order of 3 or more means 3 rows, 3 columns. If you are going to deal with a matrix of the situation, order of 3 or more, that is 3, it may be in the order of 3, it may be order of 4, it may be in the order of 5. In that cases, you need to find the determinant. If you are dealing with a matrix of the order 2, here also you have to follow the determinant pattern, but sometimes in some cases it may be specified as minor. So because here -5 is the values on the base of the numbers that is written in this small matrix. Usually that number is known as minor. So whenever you are dealing with a situation of matrix of the order 2, it sometimes in some textbooks you can see that it is called as minor. And if it is an order of 3 or more, it is said that it is called as determinant. So the concept is only one thing. You have to find the determinant, and if you are getting a non-zero, then your assumption was correct. Assumption means the order of that matrix was correct. If you are getting a 0, then you have to go for the next smallest rank. So when you are going to the next smallest rank, you need to split the matrix given in the question depending upon the order which you are assuming. So this is how you have to deal with the rank of a matrix. So just go through it, familiarize each step, understand the concept. We will discuss about the further cases in the coming session. That's all for today. Thank you.